from Nuxio. And today I'm here to tell you kind of a story of how we brought in Polymer to replace our previous UI framework, which was built with JSF. So Nuxio is mostly a Java shop. We're basically an ECM, an enterprise content management, but we position ourselves as more of a platform. So we target developers, and our customers normally have their own developer teams, and they build their own applications. So it's not something that you download and you use right out of the box. It's something you customize to fit your needs. We have a bunch of customers, and we have many different applications that you can build leveraging the platform. At our core, we're a repository, a document repository. We basically work with documents. You can think of a document kind of like a JSON document, where you have a structure for this document. It's defined by a set of schemas and facets. And then in terms of REPL, how it's persisted, we have several layers of abstractions that allow us to support many different set of databases, NoSQL databases. We actually use a hybrid approach where we use stuff like Elasticsearch to do indexing. So we scale a lot, we can scale, and we provide a set of services on top of these documents. So you do the domain modeling, then we provide you with security policies, we provide lifecycle and workflows, conversion, search, auditing, etc., all around the documents that are stored in our REPL. The big thing here is that we're a very modular platform in the sense that you can pick the bits and pieces that you want to use, and you can build your own application. And the reason we can do that is because we have a runtime, which is very similar to the OSGI model, which is kind of dead today, but it's still a model. So we have this notion of services, components, and these declare extension points to which you can contribute things using XML or JavaScript contributions. And this allows us to have well-identified modules. We can test these, we can maintain this. And this is what allows us to scale and really customize the solution to everyone's needs. The good thing about this is that we have this plugin model across all the layers of the system. So at the REPL, like I was telling you about, everything is pluggable. You can switch database, you can plug in new services. Services are also pluggable, but we took this even to the UI. And like I said before, our UI today, our default UI, is built with JSF. For those of you who don't know, it's a server-side, component-oriented framework for Java. And we use facelets, the templating system, which is basically XHTML to declare the layouts. And we use rich faces, which provides a set of pre-built components to build the UI. And we made our UI pluggable. So it's a very traditional, file-driven ECM UI where you can create new documents, you can add fields to those documents, you can add blogs, you can add binaries, you have a tree navigation, and the big difference is that this UI is itself pluggable. So we have a set of regions in the UI, and you can customize this. And the way we are allowed to do this, the way we can do this, is because we have a notion of a meta model for the UI, where we have layouts, and these layouts are basically a big list of widgets with widget types bound to fields. So we have a big meta model, and to kind of protect people from this complexity that is brought in by our meta model, we provide a tool. This tool is software as a service, is Nuxio Studio, and this is what most developers look at on their day-to-day work with Nuxio. They look at the visual UI, where you can drag stuff around, and you can customize everything in Nuxio. So you can brand the application, you can add new document types, you can build layouts for these document types, etc. You can customize the results list, etc. So it's a very simple tool for you to customize the platform to fit your needs, to fit your business model. The thing is, even if our UI is really pluggable and you can customize a bunch of things, we have big customers with different roles in the company, and they want to build specific UIs for a given purpose. And they want to leverage their developers, the knowledge that they already have in the tools, like, they know given JavaScript framework, they know HTML, they know CSS, and they want to be able to leverage this to build their UIs, and they don't want to have to deal with this meta model and with the limitations that the meta model brings. And but they still want to have Studio. They still want to have the support that we provide to Studio and the ease of building and customizing the application. And We had a bunch of use cases for this. This is like one application. I think this one was built with Polymer. Was a knowledge management for pharmaceutical industry. We built a custom UI for Sharp. It was an Angular UI build. So this was becoming more and more of a trend. And it made sense at the point, since we had everything exposed as REST services. It was really easy to build UIs. But today, what we provide with JSF UI is something like this. So we have Studio, where through this meta model that I told you about, you can customize a UI we provide to you. And this has worked very well for us. So it's really simple, it's configurable, it's very pluggable. But we try to think outside the box, and we try to imagine how we could also improve the workflow of people building custom UIs like the ones I showed you. So what we wanted to achieve was, okay, so how can I provide these developers with building blocks that they can leverage to build their own UI. So instead of starting from scratch, and I want to build an Angular application, I want to build a Polymer application, React, instead of having to start from scratch, we wanted to provide them some sort of tools and elements for them to build their own UIs, and we'd also leverage these to build a new UI for ourselves. And this made us look for a different component framework, where components would be these building blocks. And this kind of led us to starting work on Nuxio Elements like 1 year ago. And when we started looking for a component framework that we could use in JavaScript, in HTML, you know, very native to people who do web development, we just bumped into Web Components, and even the name just kind of gives it out. So these are components for the web, and they're provided out of the box. They're standard. They're provided by the platform, by the browser. It's basically a set of standards. Some of these won't make it. This is kind of a living standard. Some of these have had different iterations. But we have things like an HTML import, which allows you to manage the resources that a given component needs. So if I have a component that needs JavaScript, needs HTML, needs CSS, I can just use a single line import and get all of these as a bundle. We have Shadow DOM, finally, which provide us like these boundaries in the shadow, in the DOM. And these subtrees are perfectly isolated. You don't have CSS rules, clashes, and it improves performance. We have HTML templates, finally, which is an inert element that you can use in HTML to use as a template, and you can stamp it multiple times. So you have, finally, a templating mechanism native to the browser, and we have custom elements. And this, for us, was the big selling point, because finally, we can have custom tags in HTML. We can finally extend the vocabulary of HTML. You're not restricted to the set of tags that you get in the standard. And working with HTML makes it so simple to understand, because everybody understands HTML, and it's reusable, it's a standard, and there's no lock-in. So if we try to do the match between what we had with the JSF framework and Web Components, we see that there are big similarities. Whereas here we had XHTML for templates, there we have HTML, we had a JSF component tree, which was managed server-side, and now we can just use the document object model, which is managed by the browser. We had custom components in JSF and custom tags. In Web Components we have custom elements, and here we had beans written in Java, and here we have pure JavaScript. So it's very similar. We're just trying to bring our component framework from the server side to the client, and the paradigm is very similar. But then we went to look into, okay, so how do we build these custom elements? So should we use like a framework, a library? Should we go vanilla? And then we ran into Polymer, which is awesome work being done by a couple of people from Google. And the good thing is that it's really simple. It just tries to help you build custom elements. So there's no magic. They just leverage the platform. They leverage what is in there and just make it simpler to use. I like to think of Polymer as kind of like a jQuery for Web Components. It just makes it nicer to use, and it also protects you from the constant changes in the standards, because not every standard that I showed you before is final. Some of them have had iterations, like Shadow DOM. We had a V0, now a V1, and using Polymer, it kind of abstracts this, and you can be sure that your element will work today and hopefully in the coming future. Also, out of the box, they have a very nice catalog of elements that you can use. They have elements to help you lay out an application. They have core elements. These are really interesting because the Polymer team is a big fan of the mantra that everything is an element. So even non-visual stuff can be an element. An AJAX request can be an element. And it makes it very declarative. Being declarative, it's good for us because it allows us to parse this XML. So we can parse it in Studio. We can provide tooling for that. We can ensure maintenance because we can parse, evolve. So it's very good to have a very declarative nature in how these things work. And also, like I said, even if an element is built with Polymer, you can just use it as any other element. So you load a bunch of polyfills just in case, and then you import your element, and then you can use it. So you can build your own tags, and you can use this, you can drop these in a plain old HTML page, and it just works. So it's very interesting for us to have this sort of power. And the big selling point for us was the fact that these elements are not bound to a framework. We really wanted to try to stay away from the framework wars. I know we have a panel right afterwards trying to discuss Angular 2 versus Polymer, but to be honest, for us at this point, Polymer is just a means to an end. We wanted to build custom elements. Polymer was there to help us, and we're not promoting Polymer as a framework for building applications. We did this because we didn't want to enforce a framework on our customers. Some customers like React, some like Angular, some like Ember, Aurelia. We don't want to force a given framework. And choosing Web Components was a big part of that, and Polymer, like I said, should be just a detail. I wanted to give you a quick start on Polymer. Is anyone in the room familiar with Polymer? No? You're familiar? Is anyone not familiar at all with Polymer? Okay, I'm going to try and give a really quick 101. I'm sorry, this is going to be fast because I have a bunch of slides. So, everything in Polymer is declarative, including the declaration of the element. If you want to build your own element, you just use this DOM module to declare it. You give it an ID, and this will be the tag name for your element. Then we have this template, which is a standard that I told you about. This is a regular node in HTML. It's a template node. It's an inert node, meaning that it's not interpreted. You can have a script inside a template node in an HTML page, and this script will not run. So it's there, but it's dead. And you can stamp it multiple times. Then, using this template, you can declare the local DOM for your element. You declare the template for your element, what it renders. You can include the styles. And here I just included for showcase the content. This node is an insertion point. What it allows you to do is, this will be a slot that you can plug in custom HTML when you actually use the element. So if I'm going to jump to the usage really quickly for you to understand. So I have here a content node. My element is called contact card. When I use contact card, I pass along some content, and what will happen is that this content will end up here, where this content node is. So it allows you to plug in HTML to your custom element. Then the actual declaration of the element is here, is a script. They provide you a Polymer function. You just pass it along the prototype for your element. You have again the is, which will be the tag name, and you have a bunch of properties. And with this, if you just use it, you get something really nice, which is this. Okay? So in terms of API, like I said, even if we're using Polymer, we wanted to stay independent of any framework. So our only concern is the API that our elements expose. And what does this API consist of? If you look at an element, when you use it in HTML, the first API that you have are your attributes. So these attributes are the properties that I showed you before. These attributes will end up here. If I have a start property declared here, I can use it as an attribute here. The same thing will apply to this my element. This would mean that I would have a property called prop, and it would get a value. And the cool thing that Polymer does, it handles the deserialization and serialization of the values. So I could pass here a JSON. If my property was an object, it would be parsed and it would be deserialized as an object. You can use booleans, you can use arrays, which is JSON, you can use dates. So Polymer handles this. What else do we have as a public API in an element? We have the methods. So in the prototype of my element, I could easily declare here any method that I wanted to have. And then if people wanted to use this method, they can just, look up my element and call it, do stuff, and it will work. This is the API that we're exposing. the last bit of the API would be custom events. So in my element, I could just fire a given event, and people could register listeners, either programmatically or in a declarative way. So in terms of API, almost everything that Polymer allows you to do is native with the platform and makes it really easy, or should be easy, to integrate with other frameworks and use even with vanilla JavaScript. Also, Polymer, like I said, brings in also some nice things over this. One of those things is data binding. So you have, I'm guessing that most people are familiar with the concept of data binding. So you can have one-way binding where data propagates downward from your host element to any other child in your local DOM. And you also have two-way binding, where you can have this two-way synchronization between values in your child elements and in the host. And the nice thing about how Polymer implements this is that it's really simple. There's no magic whatsoever. It's just a bunch of setters and some listeners on events. And I actually wrote a blog post. I can share the presentation afterwards if you're curious, where I try to deconstruct how the Polymer does data binding for you to understand. Another thing that Polymer gives you is a bunch of helper elements for you to build the template of your element. So it gives you the regular stuff in any templating engine. It gives you ability to repeat over a given list. It gives you conditional templates. And here you can see I can use data binding with methods. So I could have an isAdmin method that took a user. And what would happen is that this method would be evaluated every time user changed. And this would only be stamped when the condition was true. So this was my really quick Polymer 101. I hope it was enough to get the general idea. Now I wanted to get into the reason I'm here. I wanted to, like I said, tell the story. Sorry for the shameless plug moments. I had to kind of explain our situation and why Polymer for us was important. And here I'd like to start telling you the story of how we moved from JSF to a whole new UI and some of the challenges we had in the process. So the way we tackled this was to start small, to learn, to prototype a lot. And prototyping consisted mostly of building these separate applications using our REST APIs and some elements that we started to build. This was how we kind of got into the Polymer to get the right feel for the framework itself. Then we started to integrate this into our UI, and we started to delivering this along with the platform to customers to get feedback, to see if it worked, and to understand better what problems we might have. And we did this incrementally, not in one go, just rewrite everything from scratch and hope it works, and it wouldn't work. So like I said, one of the first things we did was we took one of the components that we had, in this case was something that allows you to manage permissions in a document, and we rebuilt it from scratch with Polymer. And as you can see, this is integrated in the JSF application, and it worked. So it really allowed us to step by step evolve our REST APIs, learn more about Polymer, and also learn how these custom elements can be integrated in other server-side frameworks or even client-side frameworks. This is kind of very specific. So even integration with JSF for us was really simple, because you can kind of forget about everything here. This is just a bunch of imports. And then when you actually want to integrate your element, since it's just HTML, you can just drop the tag there and it will work automatically. So it really allows you to incrementally move to Polymer, move more things to client side, start replacing small bits in an application that you have that is server side, and really make the jump. And with the benefit that these elements that you build can be reused by other people, by your own team to build different UIs, so it's really interesting. We like the concept so much that, okay, let's just remove small things and do experiments, that we did a bunch of similar experiments. One of those was for data visualization. We needed to build a set of dashboards, so we went with Polymer again. We built some data viz elements that allow you to build nice charts over data that we had in Elasticsearch in Nuxio. And at some point, as we evolved, we started ending up with our own element catalog. So we have, I think, like 60 elements at this point. And they're grouped like core elements, UI elements, data viz. We just took the Polymer catalog that they provide, that is open source, plugged in our element definition, and we have a nice catalog with documentation and demos. So it's a really interesting way for people to learn about the elements and start to really use them. Then, when we had this good knowledge about Polymer, about the elements, and since we always said that the ultimate goal was to allow people to build their own UIs, we had to give it a shot. We had to try and actually build a UI using the elements that we had. And this led us to what we called initially the new Web UI. It's basically a rebooted experience on a completely rebooted technical stack. Okay, this is marketing talk, but that's what happens. So I have here a small demo. We'll try to explain to you what we're looking at. I'm going to make it faster. So this is what our Web UI looks like today. Almost everything that you see here are elements that you can take and you can use them to build your own UIs. We kind of adapted some data table elements. We built our own data lists, our own data grids. We leverage a lot iron lists to provide infinite scrolling and to really optimize the scrolling experience. Even each button that you see there, each action is itself an element that people can just use to build their own UIs. We played with inline editing, which we didn't have in just JSF UI before. We played around with the notion of the tree navigation. So using elements really allowed us to experiment with things, because if you build your own application thinking about elements, it really forces you to kind of decouple them, which means that hopefully you can remove one implementation and add another. So it allowed us to experiment with the UI, and with new user experiences. We added stuff like quick filters. You can save searches. You can recall the searches that you added. So in terms of features, it's not that far away from JSF, and even in terms of the user experience, how it looks like, it's not that far, because it's very difficult to come up with a groundbreaking UI in this space, where our product is directed to business customers and they're used to that UI. So we're trying to, in small steps, come up with different approaches. So we have collections of elements. You can navigate through this. The interaction is really fast, because most of the stuff is just doing a quick REST API call instead of being JSF, where you have to re-render the whole page. And let me try and see what I have to show. So we also played around with something like this, our clipboard. We played around with local storage. So the clipboard, you just store an ID for a document in local storage. It's really cool. We evolved a lot the analytics part, the dashboard, a bunch of custom charts built, and what else we have? Administration. Yeah, we played around with themes, because Polymer also really leverages the standard, the CSS properties. It gives you CSS mix-ins all running client side. So it was very easy for us to experiment with what the browser can give you out of the box for free. And so far it has worked really well for us. We'll just try to move forward. Okay, so what is the Web UI? As I said, the main goal of this was to really use our UI, our core, Nuxio, and database elements. We wanted to make it simple. We really wanted it to be like an example of how you can build your UI, and for that to work it needed to be simple to understand. We removed the notion of the meta model, and because like I said before, whereas before you had the meta model and you could build your custom layouts for your own document types, your tabs, etc. to this meta model, now we just use custom elements. So we just build custom elements for any layout and we can load them, and we really wanted to leverage the platform. And one of the things that we took a risk at the time, because this is something that we have been working on for like a year or something, is should we use Polymer as an application framework?
Responsive web design. So let me show you what this responsive web design is all about. Let's just open this particular slide.
Video
This
sai
is
atrás.
my profile on WhatsApp.
Good
This is
video.
about me, and this is the one that now what I'm
Cool.
Video.
Ah, 2-speed video. Good. Sorry about that. And so, like I said, Polymer was not built as an application framework. I told you this in the beginning. Things have changed today, and they came out with an app toolbox, which is really cool, a bunch of elements and technologies for you to build progressive web applications. But at the time, we didn't have anything like it. and even the Polymer team was still learning these patterns. So we bumped into a lot of interesting challenges that we needed to address. I'm going to give you a quick overview because it's a bit technical, but just FYI. So one of the first problems that we and almost everyone has when working with Polymer is how do you control the data loading? Because if you have an element that it's very cool, you can just drop in a page and you get a list of data that comes from the server. In theory, it's a really interesting element to have, but then when you start adding multiple elements like this in a page, all of a sudden you have 300 requests that you don't know who is actually doing what, and they're even doing the request when they're not visible. So it's a difficult thing to manage, and we played around with just using the conditional stamping, because if you do this, you can control when something is actually stamped in the DOM, and it will only trigger the request when it's stamped, when it's created. We played a lot with iron pages, because iron pages is something that you see in all the examples, in all the Polymer examples. They have this cool notion of iron pages, and then you just have a bunch of sections here, and it acts most like a switcher. It's like a stack of views. You can just switch between one and the other. The thing is, all these pages are there in the DOM, but most are simply not visible. The thing is that these elements, if they're data elements, and if they're set to automatically fetch the data, even if they're not visible, they will still fetch the data, because they don't know they're not visible. And so we found out about the selected attribute, and we can just inject this attribute into the page and only do the data, load the data when the page is visible. And also another approach is to use on-demand elements, which is what the Polymer team is now using. If you plug this into a router, you can just import the element when you need it. And this way the element is not there, it's not in the DOM, so it's kind of dormant. And only when you load the page, it will fetch the element and then will render, trigger the fetch of the data, and everything will work as expected. Another big problem is data flow. Because if you try to work with cool stuff like two-way binding, it's a really cool concept to have when you have a small application. And for Hello World examples, it works really nicely. But when you move to a big application, it can become messy, because you then need control of who is changing what data. And this led to some patterns like Flux, mostly in the React community. But the principles are very simple. It's easy to map the concepts from a Flux architecture to Polymer. Because if you replace actions with events, if you replace a dispatcher with an event handler, a store can be just your element that will store the data, and the views are just templates. You can force yourself to use a one-way data flow where you have your host application storing the data and acting as data store and just distributing this data towards its child elements. And when you need to update data, it shouldn't be a child element changing this data and propagating these changes through two-way binding. It's easy to just fire an event and refetch the data here on your data store and then propagate the changes. Otherwise, it will be a big mess, because you have a competition between who is asking for what, and it's really difficult to manage. Okay. Then another problem that wasn't solved at the time is how do you handle internationalization in a Polymer application. Today they do provide you a solution, but we wanted to come up with a decoupled internationalization solution, meaning that our elements themselves would support internationalization, but we didn't want to force a strategy to load the labels in your application. Perhaps it doesn't make much sense, but well, it's a problem we had, and we used internationalization behavior, which is basically a mixin, and we basically have a very simple binding helper that you can use. You just pass it a key and you get the translated message, and then you can change the language. It will load the JSON with the new messages, and thanks to data binding and events, the UI will refresh with all the right labels. Again, we have a nice blog post written by Gabriel on this, if you want to have a look afterwards. We had to work around routing. We started with page.js, which was what they used as a showcase, but we needed to do reverse routing, meaning that when you looked at all the examples that they had in the Polymer GitHub page, all the examples used hard-coded hrefs. And we needed to have hrefs to allow you to kind of right-click, open a new tab. We didn't want to have just a single-page application with no hrefs and no changes. So we came up with our, again, routing behavior that you can mix in your element. and you have a URL for, you give it the name of a route, a bunch of parameters, and it builds the href. So we had to fix this ourselves. Again, another blog post that we wrote. And then the final problem, very specific to our needs, was the pluggability. So like I said before, JSF UI was really pluggable, but we also wanted to have some degree of pluggability in our UI. One of the simplest ways to do that was to just do dynamic imports, like I told you. So if I can just import a page when I need it, it's not vulcanized. Vulcanization is a process where you kind of concatenate a bunch of resources into a big file to minimize the number of requests, which you need to do unless you're using HTTP2. And so if you exclude it from vulcanization, you can load it on demand. And if you can load it on demand, it means you can simply override the current HTML and you have some degree of customization of the UI. Another thing we did was to also do dynamic loading, but based on a convention. So if I'm looking at a certain document type, let's say a note or a picture, I can load a specific element for that type of document and have a specific layout, a specific form for that document type. This again gives us another degree of pluggability. And the final one, which is the most complicated one for our needs, was slots. So I named it slots because it's something that comes in the V1 Shadow DOM spec, and it's very similar to the insertion points that I showed you before, you know, the content node where you can inject HTML. So slots are basically this as a standard. The thing is, you can only reference a slot when you instantiate the parent. So if I have like my page, I can tell it, okay, then this content goes to header, this content goes to body. You have slots well identified, and you can plug in your custom content to the regions you identified. In our case,